Hello, everyone. Welcome to CSINext February chapter meeting. I'm Mark Ogg, your current president. And today we have with us Tony Sola from Acoustical Consulting Services, who will be talking to us about the role of acoustics in responsible design. But before we get started, I'd like to take a quick minute to thank our longtime chapter supporters and sponsors, Architectural Woodwork Institute, National Gypsum, Northern Facades, KM Architectural Consultants, ATIS, and Daniel Hargreaves. Your continued support and involvement has helped this chapter continue to grow, provide our members with a unique virtual membership experience from anywhere in the world, and it is much appreciated. So speaking of members, before we get into anything, I would like to congratulate CSINext members Andrew Nielsen and Laura Garland on obtaining their CDT certifications in the fall 22 testing session. And also I'd like to recognize chapter member and chapter director Stacy Sire for achieving her CCCA certification. Congratulations to all of you. Also Denver chapter member Daniel Gonzalez, who was unable to join us today. He participated in the CSINext and Columbus State Community College boot camp put on back in November through the CSINext chapter Dean's prep class for the CDT. And Daniel reached out to me the other day and let us know that he was very appreciative of that prep session, and he also obtained his CDT as well. So congratulations to all of you folks. Job well done. I have both my CDT and CCCA, and I know that they are not easy certifications to obtain. So job well done, and I'm sure all your efforts will be rewarded. So with all that, I'll bring on Tony Sola, and to introduce to you Tony, we have CSINext Director Stacy Sire.
Good morning, everyone. Thank you for taking time to join us for a discussion about acoustics. As I look back over the course of my design career, I've noticed that it's not always the actual design or construction that results in issues or complaints. In fact, many times it's not. It seems to be a mixture of perceptions and expectations that revolve around what we all know as environmental factors, like light levels, things that, light may be great to me, but like to my husband in the same room, he thinks it's horrible. Other factors are temperature, and of course, acoustics. What may be tolerable for me in a reverberant room may not be tolerant for Mark. So being able to understand expectations is really good. It's really helpful, but we all know that's only half the battle. We all know that acoustics is really science. So in today's world of wide open spaces and increased multifamily dwellings and the like, understanding the fundamentals of sound and acoustics is really critical to client relationships. Even more so, I've been in this industry over 30 years. I've learned that to find and sidle up to passionate professionals who complement a design team and who are passionate, literally passionate to understand and solve acoustics questions in particular has been just a saving grace for me. To this point, I'm very happy to introduce to you not only a consultant that I've known and worked with for over 20 years, but also a friend. Tony has been working as an acoustical consultant for over 30 years, and he's the president of ACS. He's worked on over 4,000 projects as a design phase consultant, code verifier, acoustical tester. My favorite that I want to get more stories about as an expert witness in testimonies, consulting for municipalities, architects, builders. He is a full-time member of the Institute of Noise Control Engineering, which I think is a feat unto itself. That's something I could never, ever do. And he's a member of the USGBC. In addition to his work for ACS, he's taught acoustical, architectural acoustics to interior designers and architects right here at ASU, Arizona State University, for over 25 years. He's lectured and taught at other local schools and universities. And on top of that, which he doesn't know I'm going to say, he definitely loves life. And I've recently found out he has an awesome goal, and that's to visit and eat at the world's top ranked restaurants, from which he just got back from Denmark and has crossed the #1 off his list. That's a different story. Maybe if you ever have a relationship, we can get more interesting facts about that. But take it away, Tony, and thank you for being here today.
Absolutely. Good morning, good afternoon. I want to talk about the integral role of acoustics in responsible design. But first, we have to understand what I might think responsible design even means. Normally, I would open this up to a quiz to see what you think responsible design is and see how well it matches with my list, but we'll go a little quicker today, and it's a little harder to just shout out answers. So to me, my keyboard, oh, I told you we didn't get through it yet. Okay, don't know why that took too long to switch. Responsible design, you absolutely have to consider health and safety. We have to look at how the person feels within our space, and comfort's usually an important aspect of that. Not always, sometimes you don't want them to feel comfortable, but often you do, but how they feel in the space is a part of responsible design. Efficiency or productivity is part of responsible design. The space has to function. Don't care what it looks like, don't care how sustainable it is. Well, I do on both of those. But if the space doesn't function, you're rebuilding walls, you're ripping out and replacing product. The space must function for a space to be successful. It's not often we don't have to consider acoustics. Those are really fun projects when you don't, but usually budgets. Did I say acoustics? I meant budget if I said acoustics. We don't often have a project without a budget. Normally we do, and that's an important part of responsible design, is considering the budget. Definitely need to consider aesthetics, and hopefully should always consider sustainability. So let's talk about how acoustics is part of each of these categories that I believe are an important part of responsible design. Hey, switched perfectly. Normally, when you think of the role of acoustics and noise in health and safety, your first thought might be hearing loss. It is a big issue. Hearing loss is a very common occupational hazard. It is 100% preventable. Aside from occupational hazards, we suffer hearing loss across the age ranges. Definitely an issue among baby boomers. As we age, we will, particularly men, will start to lose the higher frequencies. But what's shocked me is how many different age groups have hearing loss. I've read stories about the percentage of increase in grade schoolers over the last 10, 30 years, and it's like 500% increase in hearing loss in grade schoolers. I read a study about freshmen in college where 50% of them had some level of hearing loss. And I thought that was too high. I thought that was exaggerating. But in my class that I've taught over 25 years, I'll always play through the frequencies so they have a feel for what that means when I talk about frequency versus decibel levels. And somebody that's young and good of hearing should be able to hear from 20 hertz all the way up to 20,000 hertz. And the number of times over the last 20 years that even 1 or 2 students per class can hear all the way up to 20,000 hertz is very, very rare. So that 50% quote that I thought was overstated, it's probably understated. We all age groups are suffering from some form of hearing loss, or a large percentage of people are. Baby boomers are again, the ones suffering the most. First generation to purposely expose ourselves to loud noise, loud concerts, recreationally, loud motorcycles, loud snowmobiles, headphones. We have purposely exposed ourselves to loud noise. We also have all been taking ototoxins throughout our life. There's about 220 different ototoxins that have been identified that will at least temporarily increase your susceptibility to hearing loss. That would include penicillin, moxicillin, anicillin, Pepto-Bismol, Nicorette. There's about 220 of them. Now, I'm not saying don't take penicillin. What I am saying that your clients, the users of your spaces might have suffered hearing loss or have even temporary susceptibility to hearing loss in the spaces we are designing and building. Aside from loud noises causing issues, it's shocking to me when I first learned how many other health effects there are to noise and acoustics. Any stress-related illness can happen from noise. We are stressful and noisy environments. That's the next slide. It can cause headaches, high blood pressure, heart problems, respiratory issues, digestive issues, even negative fetal development. So if we are concerned about health and safety, we absolutely have to be concerned about noise and acoustics. Again, we should care about how people feel in a space. Again, sometimes you might want them to feel a little uncomfortable, but comfort is an important part of a lot of different space types. And acoustics and noise is definitely a potential impediment to comfort. We get irritable in noisy spaces and might not even realize we are. We are antisocial. We are hostile, we are violent, we are even murderous. I bet if you went online right now, you could find a recent story about somebody trying to kill somebody else over loud noise. I've yet to come across a story about that with lighting or HVAC. So if we care about comfort, we absolutely have to care about acoustics. We're just irritable in a noisy space. You are less likely to get a good peer review if you work in a noisy space. You're less likely to get a good restaurant review if it is noisy. We'll talk a little bit more about restaurants. But again, if you care about how people feel in a space, you have to care about acoustics. Efficiency is absolutely important in responsible design, but so is productivity. Energy efficiency in a typical commercial office environment, your energy bill is probably about $1.50 a square foot, but your labor costs are about 100 times that, about $150 a square foot. So on the projects that we're working on, if we can create a project that improves productivity by even a couple percent, that's a big impact to our client's bottom line. And acoustics and noise is the #1 impediment to productivity. We cannot concentrate on our own projects or on our own work if we're distracted by noise, particularly if the speech of the next office, somebody talking in the next office or the next cubicle or a few cubicles away, if you understand what they're saying, it is very difficult to concentrate on your own work. It's very difficult to divorce ourselves from a conversation that is intelligible to us. So if we care about our clients' productivity, we have to consider acoustics. Again, functionality to me is vital. Acoustics is an integral role to virtually every space type. Most people would think of concert halls, recording studios, but it's really every project we work on. Anytime we need to have speech intelligibility, so that would be courthouse, boardroom, classroom, any place where the PA system is important to understand, airport, DMV, bingo hall. I've worked on many bingo halls. You can't even imagine how upset people are if they do not understand the PA system when they're calling out B14. Sometimes we don't want to understand speech. We want speech privacy or even confidentiality, attorney's office, medical facilities, HR departments. We have to consider acoustics in any of those spaces. Where music is important, or more difficultly, where both speech and music are important. A good acoustic environment for music could make speech unintelligible, and a good environment for speech could make music sound dry and flat, depending upon the type of music that they were playing in that space. So any multi-purpose space, a theater, a worship center, auditorium, a ballroom where we'll have speech and music, we need to consider acoustics. And with a worship center, that's not just important to them, both the speech and the music are sacred to them. So we absolutely need to consider acoustics in those spaces.
Hey, Tony.
Yes.
Quick question. Is there anything that is considered too quiet? If that makes
Absolutely
sense.
And it goes to comfort. It also goes to, we want some activity to possibly mask transmitted noise. An office space that is too quiet will have acoustic issues. You'll be able to hear the transmitted noise very much easier. And again, the comfort, if it's too quiet, well, that's more too dead. But yes, definitely there's an issue with too quiet. Restaurants is a great example of that. where most restaurants, we don't want them to be too quiet. We want a live, active feel. It feels weird to be in a restaurant that's extremely quiet. So usually we want that live, active feel, but if that gets too loud, so there are a lot of spaces where we want them to be loud, but if they're too loud, then it's absolutely an issue. The number of restaurants I've worked on, because they actually want it to be loud, but if it's too loud, the wait staff might not understand the order. They'll bring out the wrong food. Now everyone's waiting for that person to get their food. You have a slower turn on those tables. So yes, important to not be too quiet in some spaces, but we always have to make sure it's not too loud. This is where I'd normally quiz the audience as to, is there any sort of project they have worked on, project type that they've worked on or might work on someday in the future that I haven't had to work on at some time. Since it's hard to write in, I'll give you some examples. Desk school is a very common response to that. Yes, I've worked on them, and I would argue that that is acoustics in that type of space is as or more important than in a standard classroom. Depending upon where I've lectured, people have said barn a number of times. I've never worked on a barn as a barn, but I've worked on a number of them converting to a different use. And one time somebody said space station, and they got me. Hadn't worked on a space station. But within months of that lecture, I was contacted by NASA working on the space station, and the person was trying to write the allowable noise specifications for the equipment in the space station, and I told them what to do for that. So I have now worked on a space station. Really, any space we're ever working on, we should at least consider acoustics. The number of architects, designer, builders I've come across that thought they might have an issue, but decided to just do it that way anyway and wait and see is never a good answer. We need to consider acoustics in the design phase before it's built. Budget. It's always more costly and difficult to fix an acoustic product after construction. You will limit your design options, you'll compromise the aesthetics. You need to consider acoustics before it's built. Once it's built, it is much more difficult and costly to fix. And there are sometimes there's no fix. And if we don't have questions after the fact, after the presentation, I'll tell some stories about projects where there was just no option with what they did. They could have had any look they wanted. They could have had any special features they wanted if we considered it up front. But once it was built, they couldn't have what their original intent was. So if we care about budget, we do have to consider acoustics and consider it as early as possible in the design phase. Ideally, we're always considering sustainability, and acoustics is one of the places where we can specify sustainable products. But I'm assuming most people realize that sustainable design isn't just recyclable products, but it's all these other things we've talked about, health and safety, how you feel in the space, efficiency, productivity, functionality. Those are all important parts of sustainability. And as I've hopefully shown, acoustics is an integral role to all of those. With sustainability, and I could lecture just on this and often do, virtually all of the sustainable goals, to meet the sustainable goals, we have to consider acoustics. But unfortunately, most of the sustainable strategies will hurt having a good acoustic environment that is needed to meet the acoustic goals. We're using fewer materials. We're having an exposed deck instead of a ceiling. Increase fresh air, increase windows for daylighting. All of these things have acoustic implications too, and usually a negative acoustic implication. So I'm not saying don't do these, just as we're working on sustainable projects, know that it's vital to have good acoustics, but it's more difficult in sustainable projects to achieve good acoustics. Okay, now that hopefully you have realized that we should be considering acoustics, on virtually any project we'd ever work on. And if you'd like to write in some suggestions of projects you think we don't care about acoustics, we can answer that at the end. And now you know that we should consider it before construction. Need to talk a little bit about what we should consider. Three important categories. One's the room acoustics. Other is noise within the space, and the other is isolation, either structure-borne or airborne isolation between spaces. So for room acoustics, one of the primary descriptors of the acoustic environment is something called the reverberation or reverberation time in the space. Reverberation is a function of two things, and really two things only: the size of the room. The larger the volume, the higher the ceiling, the more reverberant the space will be, and the amount of absorption in the room. If you have a high volume ceiling with virtually no absorption, you will have a reverberant space. And when you have a reverberant space, you will have a buildup of noise from those reflections, and you will reduce speech intelligibility. So that sounds like reverberation is bad. It really depends on your use type, your space type, and the use in that space. In a concert hall, you want reverberance for people to be enveloped within that music, for the notes to blend together. And so a higher reverberation time would be a good thing in some music performance spaces. But where we care about speech, you don't want words and syllables to blend together like we want notes to blend together. So high reverberation time will really hurt functionality for a lot of different use types. Even if you get the reverberation perfect for that particular use type, we also need to consider reflections. A slat back is in any sort of presentation space where the presenter, the lecturer, the person giving the sermon, the teacher, I guess I said lecturer, the band, the judge, if their performance, if their program hits the back wall and is slapped back to them, it can be very distracting to them. If you've ever tried to talk on your cell phone when your own voice has been echoed back to you, you understand you just can't do that. So controlling the slap back reflections is vital for any sort of presentation space. Flutter echo or standing wave is a buildup of reflections, almost a ricochet, where it goes back and forth between parallel reflective spaces. So that's usually conference rooms. We have parallel reflective spaces. We can get a flutter echo in there. That can cause an issue. Focused reflections can be a big issue. A peaked ceiling, even a corner, you get a megaphone effect with any sort of focused reflection by a peak corner, by a peak ceiling or corner, barrel vaults or any concave surface. And the worst is a dome. It acts as a satellite dish and focuses all of the reflections. So any of these types of reflections we need to try to control. I'm not saying don't do a dome, just realize we will need to look at it acoustically, or we will likely have an acoustic issue in that space. The way we control both reverberation and reflections is through absorption. For reverberation time, theoretically, the absorption can go anywhere. We can put it on the floor, the ceiling, a combination, the walls, really anywhere within common sense, we can put the product and control the reverberation time. Common sense would be if you're putting up wall treatment and then putting a bank of file cabinets in front of that, obviously, you're not going to, that absorption is not going to be as effective anymore. I've seen a number of restaurants put absorption on the underside of their seats and think it actually did something. The reflection that hits the underside of the seat really isn't impacting the room anyway. So proper placement, you need to use common sense, but really can go anywhere for reverberation. For reflections, it absolutely has to go where that reflection is occurring. The number of times I've had architects think that, and contractors think that adding absorption to the walls or the floor will solve the focused reflection from a dome. It does not. The absorption has to go where the reflection is occurring for it to be effective.
Hey, Tony.
Yeah.
Question on that. So when you're talking about the knowing where the reflection is going, is there a method to determining that? Is there, I mean, I know we've got all kinds of modeling software these days. Are there ways to figure out, okay, we have this wall assembly and we're putting this stuff on it? Is there a way to see where sound is going to go?
Not see as much as hear, and critical listening is usually what I'm doing in the spaces, and this works with reflections, but also with transmission. If it doesn't have to be me in there listening, any layman can listen for where they think that reflection might come from. If they're standing on the stage and it's being slapped back to them from the back wall, it's obviously the back wall. Once they know what those potential reflections are, they can better identify where they're coming from. Same with transmission. The number of times, we'll talk about this a little bit in the next couple slides, the number of times I've gone into an office where all of the noise transfer is coming through the gap at the mullion, but no one ever realized that. And it's so easy once you're listening for where the noise transfer is happening. So you're right, we can computer model to try to feel reflections in the field. We can try to get a feel for it. It's a little difficult to figure out where the reflection's coming from, but with knowing what the different problematic reflections are, it's easier to just identify by listening. But yeah, good question. You had another one?
Okay.
Okay.
There was one comment. Someone's talking about there's acoustical gypsum board.
Yes.
Acoustical rated. How is it absorb? I can't.
Both. There's
Absorb
each, and that's the
reflective.
confusion.
Okay.
Is acoustic drywall is a term that people throw out all the time, and acoustic drywall used to only be like quiet rock that is a little better at isolation. It does nothing for absorption, but is better at isolating than drywall, right? Standard drywall. However, and as we'll talk about, it all depends on the weak points. So you could add 4 layers of quiet rock, or even 4 inches of lead, and if you have a weak point, the noise is still going to go through the weak point. But in the last few years, we have a couple products come out that are great products that are also called acoustic drywall that are absorptive. And those, you need to look at the NRC rating of those. If they list one, then it's absorptive, and if they list one high enough. So there's a couple different products, both USG and Armstrong have their acoustic drywall that are absorptive drywall. Our industry standard is NRC, noise reduction coefficient. There's so many issues with that standard, starting with the name. It implies that you will reduce the noise in the space by adding this absorption. That is not necessarily the case. It reduces the reflections in the space. We need to talk about acoustic transparent versus acoustically absorptive. There are some acoustic products we can put up that the product itself might be the surface product or the product you see. But usually we want something in front of that to protect it, to be able to clean it, or just for the aesthetics. So normally we have an acoustically transparent material like fabric, perforated metal, slatted wood in front of our acoustic core. For that product to work, for that system to work, that face piece needs to let the sound through to be absorbed by what's behind. If you have drywall in front, only the low frequencies are going to go through. NRC is just an average absorption at 4 frequencies and 4 frequencies only. They're right in the mid frequencies of speech. So one of the concerns is NRC only tells us what it's doing for speech frequencies. It tells us nothing about low frequencies or high frequencies. Normally, absorption in high frequencies isn't as much of a concern because it's a smaller wavelength and more easily absorbed by virtually anything, even the air. So it's those low frequency, loud bass notes that are the issue. And NRC tells us nothing about how that works for the low frequencies. There's a slight concern with lab versus field ratings. Some products, if you tested an inch of fiberglass in a lab versus a field, it should always test about the same. But there's some that are more labor intensive, like an acoustic spray. that could be completely different in the perfect lab environment versus how they installed it in the field. My biggest concern is there's no NRC police. There are very misleading, there's a lot of misleading information, and there's out and out lies on NRC. We'll talk a little bit more about that. But it is the standard we are stuck with.
What would, because I know sometimes owners will see things on drawings or be in project meetings and hear discussions of things like NRC. What is a simple way to explain that to an owner that may not understand exactly what it is? Like you mentioned before, noise reduction coefficient doesn't mean it's actually going to reduce it. And I think a lot of people, when they see that, think that's what's going to happen. And then maybe when it doesn't, they're questioning, why.
Exactly.
For somebody with not like an engineering or a scientifically based background, what's a simple way to explain what that concept is?
Absorbing the noise is not the same as reducing the noise or getting rid of the noise. It doesn't absorb the noise, it absorbs the reflection. So that's number one. We're absorbing the reflection off that reflective surface, or helping to improve that. Drywall is about 5% absorptive, so you're reflecting 95 back. I would never recommend a product that's only 50% absorptive. There's virtually never, very, very rare. You want at least an NRC of 0.50 to effectively control a reflection. And again, it is only controlling the reflection. It doesn't make the space quieter. It can help to stop the further buildup of noise from reflections in an already reverberant space, but adding more reverb absorption in a dead space might be a good thing for the reverberation time and the room acoustics, but won't make the noise any quieter. And you'll never control the direct noise. It's just the reflective noise that's being slightly reduced. Okay. So that's how I'd explain it. It's not absorbing noise, it's absorbing reflections. Two different issues that we need to understand is absorption versus isolation. NRC is our standard for absorption. STC CAC is our standards for isolation. They are completely different at often, and sometimes the opposite. The number of times I've heard of a project or worked on a project where they wanted the best ceiling tile they could get, and that to the rep and to them meant the highest NRC. So they want an NRC of 0.90 or 0.95 or 100%. That is usually the worst product you could use if isolation is your concern. So if you want the best ceiling tile to control reverberation, then maybe you would use a much higher NRC. But if you want the ceiling tile to control the noise transfer over the top of the wall, because your walls don't go to deck, then a high NRC is about the worst thing you could do in that space. So we need to not only have a good NRC rating, but oftentimes, particularly with the ceiling treatment, we need to have a good CAC rating. The NRC on a wall treatment is the important part. There's no real isolation concern on the wall from our acoustic product. And I could explain that better at the end if we need. But really, we only care about NRC on surface mounted. It's the ceiling tile where we'll often care about NRC and the isolation. As I said, I'd never use a product that's less than NRC 0.50. So if you're looking at a product that says it's 0.20, yes, it's better than drywall, but it will not adequately control those reflections. And then normally I'd want a product around 0.70 to 0.80 to be effective. You need to make sure whatever mounting procedure the product you're looking at was tested at is the way you're installing it. The number of times I've seen acoustic products that list a 0.80, but it's a 0.80 when they're installing it on an inch of acoustic core. And if you're not installing it that way, it will not achieve that. The 3mm felt products that many people think are acoustical and very absorptive, They are acoustical and very absorptive when you install that 3 mm product on an inch of acoustic core. If you're not doing that, you're only going to get about a 10% absorption. Yeah, better than drywall, but just not effective. And be skeptical. It is shocking to me how many manufacturers I've contacted that just haven't even tested, or the number of times I've seen NRC ratings that are misleading because they put NRC 0.80, but in parentheses, they say from 4,000 hertz to 8,000 hertz, and that doesn't mean anything to anyone, but really they're cheating the system, although not lying, or the number that have just flat out said they're 0.80 when they're not. They're only that if they're putting it on an inch of acoustic core. So be skeptical on NRC ratings. We also need to be concerned about airborne isolation, and that's more the CAC rating, STC rating. For a wall assembly, we'd look at the STC. An acceptable range for that is normally, if you want to control normal speech, we want to be an STC 50 or higher. If you're controlling other noises, it might need to be higher, but ceiling tile, anything below 25 is poor for an isolation on a ceiling tile. 30 to 35 is good. 40 is about the best you can get on a ceiling tile. So it's a different rating than STC. It's the rating that's assessing the noise transfer through the ceiling tile over the top of the wall and then through the next room's ceiling tile. So they don't use STC for that, it's CAC. When specifying for cavity insulation, I see very often acoustic sound blankets, which means something completely different to me, but I see that often. Cavity, and so we've said that absorption on the surface of the wall doesn't improve isolation at all. It only helps to absorb the reflections. But absorption within the wall assembly or floor ceiling assembly does improve the isolation quality. It improves it by about 4 to 6 points. That's clearly noticeable. It's about the cheapest, easiest way you can get an improvement in your isolation is adding cavity absorption. Again, to me, acoustic sound blankets is a totally different product. I see that often. I'm assuming most contractors just put in bad insulation anyway. When they see that, I'll also see specifications for sound bat or acoustic bat. Virtually all insulations, cavity insulations work well, and virtually all of them work the same. Sound bat, acoustic bat is no different than standard bat of the same thickness. Rock mineral wool versus fiberglass, I don't care what the internet tells you, they're the same acoustically for your STC rating. Spray foams, some are a hair better, but not that you would hear that difference. Many are actually a little bit worse. The only products I've come across that are actually a little better, noticeably better than every other cavity insulation is like a wet sprayed cellulose. Cell bar would be one of them. But over the years, that product is not sprayed as wet as it used to be. And they're doing it more and more like dry cellulose. And that is still better, but it's not as effective as it used to be, but one of the very few products. So when specifying cavity insulation, it's important to have it, but really what's used isn't as important. Virtually all of them perform the same. Resilient channels, we talked about, I worked as an expert witness. Resilient channels is one of the most common cases I've worked on. It is, I would never recommend, or virtually never recommend resilient channel on any wall assembly. It is too easy for them to install it wrong. It's too easy for them to defeat all of the benefits by screwing it in wrong, installing it upside down. If they ever sandwich the resilient channel between shear and drywall or 2 layers of drywall, they will not only destroy the acoustic, the improvement from the resilient channel, they could actually reduce the insulation. It would actually be worse to have the resilient channel in that condition than not having the resilient channel. So if you ever, so never recommend resilient channel for walls. Still, it makes sense for ceilings. It's harder to defeat, but a resilient clip it works much, much better and will improve both STC and IIC. We'll talk about IIC in a minute. These resilient clips instead of the resilient channels, it's very difficult for them to be crushed. It's a hat channel that clips into this isolated grommet. Those work very well and will notice very hard to install them wrong. Will help both STC and IIC. A double stud wall, if there's space and it can be designed this way in the beginning, if you have room for a double stud, that's extremely effective. And the best way to do it if you do have the room. Now, did I go back on the slide or yeah. But with one major caveat, a double stud wall can get us a very high STC rating. But if the shear or drywall is installed between the two stud sets, logic, physics, common sense would make you think that that would actually be better. We've got 4 barriers instead of 2. It is actually substantially worse if you have anything within drywall or shear within that. However, if you put the shear on the outside, so if you didn't notice, we have the standard double stud wall is an STC 56. That's a very good rating. Building code requires 50 for multifamily. But you put the 2 extra layers of drywall in the middle, you drop to a 44 and hear every word and don't even meet building code anymore. If we are able to put those layers of shear on the outside instead of the inside, then we get up to a very high STC rating. You know, we jump it from a 44 to a 63. Those are huge numbers acoustically. Airborne and is, oh, I'm sorry. That was the slide I was just repeating. Sorry. I did the aside on the double stud walls. Operable walls are rated by STC ratings, but that's almost meaningless. The way they test an operable wall is just part of the panel. So you'll get an operable wall that hits a 52 is common and a pretty good wall. The problem is you will never get that in a field. For a standard assembly, we assume there's about a 5-point drop between the lab test and the field results. In an operable wall, it's more like 15. So an operable wall that's rated STC 52 is probably only going to be like a 33 to 35 in the field. Same with demountable walls, but not as much. With both operable walls and demountable walls, you really want to look at their field rating instead of their lab rating. And that's normally called NIC, noise isolation class. Building code is STC 50. That's where we start to control normal voices very well, not loud speech. But if we are getting a field rating of, say, 33, which I don't know if you see my cursor or not, so a 33 to 35, you're going to hear speech and you're going to absolutely hear loud speech. Even if we get, and this is all talking about speech, even if we have a very high STC rating, say 60, that will control loud speech well, but bass notes are still going to go right through that assembly. If you have an 8-inch solid concrete assembly, that's going to be around an STC 55, the bass notes will still go right through that. So if you're controlling music, the specifications for the wall assemblies need to be even higher. STC is meaningless unless we control the weak points. All of the noise is going to go through the weak points. The common ones would be the interior wall to the mullion is extremely common. Anything that's recessed in the wall can hurt. Again, don't know if you're seeing my cursor. Anything that's recessed into the wall. In multifamily, that's a back-to-back bathroom cabinets will, what's the better word for that? Back-to-back bathroom cabinets that are recessed into the wall. You're basically in their same bathroom. I'm seeing more and more often in commercial offices, in conference rooms, where they're recessing the large monitor mount instead of surface mounting. They're recessing it and putting basically a 2x3 hole in their wall, all of that noise is going to go through that weak point. So we have to control the weak points. Otherwise, we're not controlling the isolation at all. In addition to airborne noise, we need to look at structure-borne noise, which could be vibration, but also impact noise. And architecturally, the codes for that would involve footfall noise. And that is IIC, impact insulation class, instead of STC. What helps IIC might not help STC. What helps STC might not help IIC. Different ways to control the impact noise. One is underlayments. As bad as the industry is at misleading and lying about NRC ratings, underlayments is far worse. The number of times I've talked to manufacturers trying to get their lab test results to see if they will be acceptable for a project, the number of times manufacturers have actually admitted to me, oh, we've never tested. Our manufacturer says on their spec sheet, or our competitor says they're 70. We know we're better, so we just put 71. They never actually tested it. And even had one manufacturer that sent me the lab test report. I called them for it. They said, sure, send it out right now. I was looking at it. It looked weird. I called the lab. They never actually tested it. They completely photoshopped their lab test report for underlayments. What's extremely misleading is all underlayments say on their spec sheets, it's STC 70 something and IIC 73 is common. Both of those are completely meaningless. It's not the product that achieves it. It's the assembly they tested it. So if they say it's 73, doesn't mean we'll get that. It doesn't even mean their underlayment contributed to that. That's just what the assembly did. What's better is to find out what it was with and without their underlayment. The underlayment has no perceptible role in STC, so there's no reason to even have it on the spec sheets, but everyone does it, so everyone has to keep doing it. It's only the IIC rating that we need to have. Building code requires a 50, but even with a 50, you will hear every single heeled shoe footfall noise from the space above you if you're only IIC 50. So we need to make sure the underlayments are good and most likely try to control it on the ceiling side as well. Again, the resilient clip systems instead of resilient channels. Resilient channels do help a little bit with that and are more difficult to defeat, but resilient clips are the better way to help control it on the ceiling side, or even just any resiliently mounted ceiling can help with the impact noise. But please be skeptical on any underlayment spec. Where should you go for acoustic resources? Unfortunately, there isn't really a lot of good acoustic resources out there. It's really just the relationships you develop with manufacturers of products that you've used, ones that you trust. Same with the product reps. A lot of times product reps will know their product well, but might not know acoustics, or they'll really just be recommending the product they rep. The number of times I've seen acoustic absorptive materials used to help improve isolation, where it was just a complete waste of money, is just so sad to me. And although you rarely will have budget for an acoustic consultant on most of your projects, just having a relationship with one that even if you don't have budget, maybe they're not helping with a spec, but just looking at the product that you're specifying or approving to see if it will really meet what you think it's going to meet. So it's those relationships are really your best your resources.
Tony,
yes.
Quick question. Somebody does. Well, I tell you what, you're at conclusion, so I've got 3 questions here.
Excellent.
We'll let you conclude, and then I'll ask them.
Perfect. Oh, that's the conclusion. Just if we consider acoustics in the design phase, specify it correctly. Don't wait and see if it's going to be an issue. We can't have a successful project.
Okay. All right. First question we got are the graphics and the tables that you showed today. Are they available on your website for reference?
You know, I have on acoustics.com, which is basically an abandoned wasteland from a long time ago, which we've actually redone it, but I haven't had the time to go through all of the text to upload it yet. But I do have some things like this. some things on stcratings.com. I could share this presentation. Maybe I can talk to you about that.
Sure.
I don't see
Yeah.
why not, but let me think about it a minute. But there are some things on acoustics.com. Don't get mad at me for how out of date it is and how unmaintained it is. Again, there's other websites that I've developed over the years, like STC ratings, particularly if you're concerned about STC ratings, then go there. There's some of this information. Also explains the STC or the absorption versus isolation better than the quick review I did.
Okay. Next question, and I think you touched on it just a few minutes ago about, when you should be bringing an acoustic consultant on board. Definitely think that's definitely something that should be budgeted in, I think from a front end standpoint. And I think thinking as someone like myself, more in the consulting role, sometimes when I'm working with owners, it's important to consider that and say, hey, here's a list of folks that we probably need to bring in early on the front end. And I know everybody likes to be involved as early as they can.
Sure.
When is a good time to make it productive for your expertise? I would just, my mind working, I'm kind of thinking, okay, it's probably somewhere after somebody gets done with their overall feasibility and schematic of kind of what they want when they start working towards actually laying out the design and doing some of the design development.
Right. I agree as early as possible, but I also agree that I don't need to be involved much in the very, very early stages, but it doesn't hurt even at the very beginning just to have a quick conversation. There might be something that they're going towards that I could steer them away from. Once you're in the design, definitely as early as possible. Absolutely, as we're specifying, the number of times I've gone into a space that has an exposed corrugated metal deck, that if they would have specified it as an acoustic metal deck instead of standard, that would have only cost, it's my understanding, like 30-50 cents a square foot. Anything we're adding after the fact is going to be more like $10 a square foot. So if they just would have specified it as an acoustic metal deck, and there's certainly some issues with that you need to talk to your acoustical consultant with. There are some that are better than others, and it might still not be enough, but if we could do it from the design phase, it's so much better.
From an acoustical deck standpoint, how is something, I've never heard of that. Interesting concept. What's it composed of?
There's a couple different ways they do it. One is very similar to the standard deck that is the fluted. My hand's not showing in the camera there. Where it's fluted, it's flat. It goes down at a 45, goes across, that goes up, and it's the acoustic metal deck in that lower flute has those angled sides perforated metal, so it doesn't look any different from 20 feet away.
It performs different,
and it has the strip of absorption within that flute.
Got it.
The sound goes through the perforated part to be absorbed by what's behind. It can be 60-80% absorptive instead of the standard metal, which from diffusion alone, even though metal is reflective, the diffusion by the shape of it, the corrugation, can get you about 20% absorption. So it's still better than drywall, and then there are other kinds that are more perforations, where they're instead of fluted, they're serpentined. I don't know that that's the right word, but they're more like a sine wave shape, or bigger flutes, deeper flutes, thicker flutes that have the perforation.
Awesome.
But early as possible, at least for an initial conversation.
Okay, great. And I think the last question we got here is kind of a two-part question. With all of the different building certifications and such that we've got, we got Green Globes, we've got LEED.
Yep.
A lot of owners are now, looking at commissioning and validation of different aspects of their facilities. What type of commissioning and validation practices are there in the world of acoustics that owners can look at to say, okay, we asked for this. Do we have it? Are we exceeding it?
There are some industry standards you can look at. There's an ASHRAE standard for background noise. It's also an ANSI standard. There's an ANSI standard for school design, for acoustics of school design, but really not a good rating system at all. However, almost all of the sustainable rating systems do have acoustic concerns.
Okay.
I don't know if it's the same version, but I actually helped write the acoustic criteria for the green globes that you mentioned.
Okay.
Lead and well is something I didn't help write, but I work on constantly.
I've seen both. Yeah, we've seen those.
Over the years that have changed, and I'm really disappointed with the newest version of well, with what they're doing with some of the acoustic criteria that are actually contrary to what I think most consultants would recommend. You've got to be careful with those ratings, but still those are the building ratings that we have that do have acoustic criteria in them.
Excellent. Excellent. Okay, well, I think that wraps up all the questions that I had.
Excellent.
Listed. Folks that are on the seminar or the presentation here, after the presentation, probably tomorrow, you will be receiving a survey on this. If you need AIA credits for participation or learning units for your continuing education and such, please fill out your email information on that survey, and we will make sure that we get it out to you. Tony, great topic. I myself am dealing with a couple of projects right now where our acoustics are of a concern, and this is very helpful. Gives me some good talking points here as we start to move through design. And again, great topic, very applicable. Did not know well, I knew there was a lot involved with acoustics, but man, you can really go down some rabbit holes. And Stacy, thank you for having Tony on with us. And folks, we will be back 12 noon Eastern time, March 9th, with our treasurer and electronics chair for CSINext, Daniel Hargreaves. He will be presenting on accessibility, comparing the ANSI and the ADA requirements, and learning the subtle and nuanced differences between the two and how to apply them. Always good to hear from Daniel, because I think he is one of the top folks around on ADA. I've known him for well over 8-9 years now, and listened to him present on this topic multiple times, and he really knows his stuff. So I think if y'all are interested, we have AIA and HSW credits available for that next month. So see everyone March 9th at 12 noon. Thank you, Tony.
Thank you.
Bye, folks.
Take
See
care.
you next month.